Chapter 3-1, we're going to be looking at fractions and decimals, okay? Mainly, we're going to look at how to convert fractions to decimals, which should be a review. And then we're going to talk about how to determine which one is greater than or less than the other one. And then lastly, we'll kind of very quickly touch on putting them on a number line. And then you'll have your paper assignment, plus you'll have your 2 Khan Academies, okay? So because this is a little bit of a review, I went back and forth last night. I was looking at the book, and the book shows a couple of different ways to, or 2 different ways to do it. One is long division and one is using a calculator. And so I decided on the homework. I want you to do the first 3 on the homework using long division. So our first couple of examples are going to be practicing how to do long division. And then on your homework, once you just do your first 3 showing me the long division that we're going to do here in a minute, after that, you can use your calculator, because really what I want you to focus on, the real 8th grade standard here, is not necessarily long division, but it's ordering them in order of highest to lowest and understanding the whole negative and positive and that aspect of it. So I want you to be able to concentrate and put a lot of your mental ability on that, as opposed to doing long division 20 times just so that you can answer the question. That makes sense. So we'll do a couple of examples of long division on your homework, and I'll go over this again when I hand out your homework, but you're going to do odds. So 1, 3, and 5 on your homework need to be long division. You need to show me the whole thing. After that, you can use your calculator, okay? And I will show you how to put it in your calculator, and then I'll show you how to recognize patterns on your calculator and that sort of thing, okay? All right, so first of all, let's look at number 1, okay? 3/5. A fraction is really a division problem, and this is the same as saying 3 divided by 5, okay? So if we write this as a division problem, okay, we would write 3 divided by 5. 3 goes under the division sign. And the silly memory trick, if you ever have trouble remembering which one goes under, I always say the one on top gets the top. So the one on top gets the top. Okay, that's just kind of I always have silly memory tricks for everything. And that's my one for division. So now 5 will not go into 3 because 3 is too small, right? 3 is smaller than 5. So we have to kind of make 3 bigger. Yes. 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 So we can't just add a 0 without doing anything else, because if we just add a 0, it changes 3 to 30, and we can't just change the number. But if we put a decimal point right here, and if we put it here, we have to put it right above it in your answer. Okay. And get in the habit, as soon as you put it in your problem, put it up in your answer. Okay. It'll just make things a lot easier for you. Now we have 5 going into 30, which how many times does 5 go into 30? 6. All right. So there's our answer. 0.6. Okay. And sometimes you'll see it as 0.6. It means the exact same thing. And for me, I don't care whether or not you put the 0 or not. Okay. It doesn't matter to me. As long as you've got 0.6 in there, we're good. And then the way you got to keep going on your long division. So you always, you say, how many times does 5 go into 30? You put the number at the top, and then you always come back and multiply your top number times your outside number. So 6 times 5 is 30 to check to see if you have a remainder. And in this case, we end at 0, and that's how we know to stop. So that's how we know that our answer is just 0.6. This is what I want you to show me on the first 3. I want you to take it all the way until you either find your repeating, which we'll do here in a second, or you get to a 0 and you can stop. Okay. All right. So now we're going to go and do this one, 1/45. Again, we're going to write it as a division problem. So the 1 is on top. So it's the one that gets the top. 45 goes outside. All right, so 45 can't go into 1, so we always add our decimal down and add our decimal up top to remind us that that's where it's going to go in our answer. And then we add a 0. So 45 into 10. Well, that doesn't work. Okay, so we're going to hold this spot with a 0, and then we're going to add another 0 down here. 45 does go into 100. It goes into 100 twice. And again, you always, yes. Yes. So then you take 2 times 45 and you get 90, and you write that down here. And now you just subtract and you get 10. And then you add another 0, drop it down, and you get the same thing you had the first time, which is going to tell you that you're going to get the same thing here if you keep going. 2 times 45, you can notice what's going to happen. You're just going to keep going and going and going, and you're never going to get out of the loop. So this is considered a repeating decimal. So how do we write our answer here? Well, we know we're not going to end at 0. So you're either going to end at 0 like we did the first example, and we know it's just a decimal that stops, or you end up with this repeating decimal. Your answer needs to be 0.0, right? That's part of your answer, 2, and then a line over the 2. And the reason you only put one of the 2s is because that's where it starts repeating. You're just going to have 2, 2, 2, 2, 2, 2, 2 forever, right? If we were to keep going. What I don't want you to do, and what some people do, is I don't want you, because up here in the answer, before you realized it was repeating, you had 2 2s. You don't want to put the line over that. Technically, that's not wrong because you can still keep repeating 22, 22, 22, but it's not 22 that repeats, it's 2. So you don't want to put the repeating sign over 22, you want to put it just over 2 because that's the number that starts the repeating, okay? All right, let's do another example here. I want to do number 2 here. So, whoops, floats around on me. 1/8 can be rewritten as 1 divided by 8. All right, 1 or 8 cannot go into 1. So I'm going to add my decimal so that I can start adding zeros, but I'm also going to put my decimal right above it. And then I'm going to add my first 0 here and check it. Can 8 go into 10? And it can go in once, right? And then you multiply 1 times 8 and you get 8, and you subtract and you get a 2. Well, I didn't get a 0, but I also didn't get anything that's repeating. So I go ahead and keep going, and I add my 0 and I add my 0. And now I take 8 into 20. How many times does 8 go into 20? Somebody tell me. Twice. So I'm going to put a 2 here. I'm going to multiply. 2 times 8 is 16. I'm going to subtract, and I get 4. I still don't have anything repeating, but I'm still not at a 0, which means I got to keep going, add another 0, drop it down. Now 8 into 40 goes how many times? 5. And then 5 times 8 is 40. And that's when I get to my 0, so I know I can stop. And then my final answer is 0.125. And I don't have anything repeating because I did get down to a 0, which stops my problem. Okay. We good there? Now, like I said, on your homework, I want you to do all of this. I should see all of this work right here on the first 3 of your homework. After that, switch to using your calculator. So we're going to do number 3 here, but this time we're going to use a calculator. So if you don't have one, come grab one real quick. So I want everybody to practice punching it in. All right, so we've got 9 over 11, and that can be written as, right, 9 divided by 11. But in your calculator, you're going to actually put it in the order. You're going to punch in the 9, you're going to hit the division sign, and you're going to get 11. Okay? I want everybody to do that. 9 divided by 11. And Damien, what'd you get? Okay, so what you should see is a pattern here, right? You've got 0 point, and I don't care if you write the 0 out front. So you've got 0.81, 81, 81, 81. So we're only going to write the 81 once and then put the repeating over both of those because the pattern is 81 and then 81, 81, 81. Okay. Now I will tell you that when you do one of the ones on your homework, sometimes patterns, if they're really long, because you can have a long pattern. I mean, it can repeat, it can go like 5 decimals, and then it starts repeating those 5 every time. On these cheapy little calculators, if you're not sure, try opening up the calculator on your Chromebook. That's going to give you a little bit longer answer, and try it on that. So if you find that these little cheapy calculators aren't quite telling you if there's a repeat, you might try your Chromebook calculator, okay? So on the ones where you can use your calculator, okay, you're going to punch it in. So like if we do 7 divided by 9, you don't have to put this in your homework, okay? We've got this. You don't have to have more examples. If I punch 7 divided by 9 in my calculator, I get point and then 7777777 forever. So I would just put 0.7 repeating. Okay. If you have a negative fraction, okay, let's do this number 14. If you have a negative fraction, your decimal is also going to be negative. Don't lose your negative sign. So if I put 5 divided by 24, okay, everybody punch that in your calculator. I want you to see this. Okay, I get 0.2083, and then what starts happening? It just repeats the 3. So just put your repeating sign just over the 3. Okay. All right, are we good with that? Make sure if your fraction's negative, make sure your decimal's negative. Don't lose that negative sign in your answer. And if you have anything repeating, put the line just over the part that repeats. Okay. All right, so this bottom part here we're going to go into, and I want to do this one first, is now we need to determine, is 7/6 greater than or less than 5/6? Okay, and there's a couple of different ways to do this, but because this section of our book is all about converting fractions and decimals, we're going to use that method. So and this is why I said this whole bottom section with the greater than, less than, use your calculator. So if everybody would at your desk, go ahead and put 6 divided by 7 in your calculator. And this is a good example where your calculators are probably, how far does yours go, Braylon? What do you get? 0.8571. Okay. So when you see that 8 come up again, and you run out of space on these little calculators, that might be a good indicator. My calculator has a little bit bigger screen, so I get more decimals. So I get 0.857142, 857, and then it keeps going. So that does repeat. But for the sake of comparing whether or not one is greater or larger than the other one, just go out maybe 3 or 4 decimals, okay? Because I'll show you here in a second why you don't need too many more than that. So if we convert 6/7 to a decimal, I'm going to put 0.8571. Okay, and we'll see if that's enough, and I'll show you how to tell if it's enough. Now I'm going to scoot over and give myself a space to put my greater than or less than sign, and I'm going to, in my calculator, put 5 divided by 6 and hit enter. Somebody tell me what we get. And it goes repeating, right? So you can put a few more on here. And here's why. You're not formally writing decimal answers here. So don't worry about being real picky about how many decimals. If you went 4 out on the other one, go 4 out on this one, because here you're just comparing the two. All right. I want to know which one is greater. These are both positive numbers. So the first thing I do is I look at my tenth spot. They're both 8. That doesn't help me. So then I got to go out another spot and I look at my 100th spot. I have a 5 and a 3. 5 is greater than 3. So this whole decimal is greater than the other one. Okay. You good? If the 5 and the 5 were the same, you go out another spot. You keep going out spots one at a time until you find a place where you're not the same, and that's where you determine whether or not one is greater than the other one, okay? Now, where it gets a little tricky with your brain, okay, and this is where it's going to kind of play mind games with you a little bit, is let's do this 21 example. I'll give you a minute to get it written down. Notice I'm not going to try to compare them until I get them both in a decimal. So in my calculator, I'm going to put 13 divided by 2. And it's negative, so my answer is going to stay negative, and it's negative 6.5. That's what this one right here is. Okay, that's what when I convert that to a decimal, that's what I get. Then I'm going to leave a space, and I'm going to put negative 6.4. Yes. Yes. So here's where it kind of plays mind games with you. When you're dealing with the negative side of the equation, you have to think opposite, right? Bigger is littler, littler is bigger. Because we're dealing on the negative side of our line, our 6's are the same, so that doesn't help us break the tie. Our 5 and our 4 is different, so there's our tiebreaker. But since we're in the negative side, our smaller number is actually bigger. Okay, so the 4, the negative 6.4 is actually greater than negative 6.5. And if you think about it on a number line, the reason why is if we have negative 6 here and we have negative 7 here, right? This is our number line, and we're used to just seeing it in chunks of 1. Negative 8's back this way, okay? Negative 6.5, which is right in the middle, is right here. Okay, that's this one. That's negative 6.5 because it's exactly halfway between 6 and 7. Negative 6.4, however, would be right here, just a little bit, just a little bit closer to 6, right? Because it's 6.4. So it's actually further right on the number line, which means it is the greater of the two numbers. Okay, makes sense there? So just watch your signs. When you're dealing in the positives, everything is straightforward. Go to your tiebreaker, whichever one is bigger is bigger. When you're dealing on the negative side of the number line, you still have to go to your tiebreaker, but then you got to bigger is smaller and smaller is bigger. You got to think opposites, okay? Are we good there? All right, I want to do a couple more examples. I'm going to do just one more. Where's it at? Number 26. There it is, right there. And I want to do this one specifically to show you what I mean about getting your decimals kind of matching as far as how long they are, okay? So the first thing I'm going to do is I'm going to convert, I'll just do it under it. I'm going to convert negative 33 over 100 to a decimal. So I'm going to put 33 divided by 100, and my fraction's negative, so my decimal here is going to stay a negative. So negative, and I get 0.33. It's not repeating, it's just an ending decimal, okay? And over here, I have negative 0.3 repeating. Now, remember I said you need to get your number of decimals to match. So over here, I have 2. So for my repeating side, I'm going to put 2 because I need to know, I need to compare apples and apples here. Well, what's the problem? I don't have a tiebreaker, right? So far, they're the same. But I know that my repeating 3 keeps going. So I can add another 3 on there. If I add another one over there, I need another decimal on the left side. What can I add there that's not going to hurt or change my value at all? Sophia? Yeah, I can add a 0. Doesn't change the value of the number. I haven't hurt anything, but what I have done is I've gone out far enough that I've got my tiebreaker. I've got 3 matching 3. I've got 3 matching 3, but then I've got my tiebreaker. I've got 0 and 3. Now, again, this is where you have to really be careful because you're in the negative side. So really the 0 and the 3 is what you're comparing. But since you're on the negative side, the 0 is going to be larger. So make sure when you're comparing and figuring out greater than or less than, make sure that you get both of your decimals out to the same number until you have a tiebreaker. And if that means adding zeros, that's okay. All right. Any questions there? At the bottom of your homework, you do have to order from greatest to, or from least to greatest. That's okay. Change them all to decimals, right? And then your biggest negative is actually your smallest number. And then you go up from there until you get to your smallest number, which is your greatest. The negative side of the number line can really kind of mess with your head. But so on your bottom of your homework, you're going to be ordering these from greatest to least. And if you want, we've got time. We can do this one really quickly. So let's do number 28 here. So I'm going to rewrite -8/9 by dividing 8 divided by 9 in my calculator. And I get -888 repeating forever. So I'm just going to write it out, maybe 3 decimals, and see if we get a tiebreaker there. So I'm just rewriting this. So -0.88, I'll do 4. Okay. That's repeating 8s. That's what -8/9 is. Then my next number is -8/10. So 8 divided by 10 is -0.8, and it doesn't repeat. But I'm going to take it out to 4 decimals. So what am I going to add here? Yeah, I'm just going to add 3 zeros. That way everybody's out to the 4th. And then my last number is already in a decimal. It's -0.80 repeating, which means if I'm going to take it out to 4, what else can I write there? 80 again, right? Everybody's out to 4, and I don't have 4 matching ones, so I know I'm good. I've got some tiebreakers here. Now, since I'm in my negative, right, first thing I'm going to compare is this first one, 888. That doesn't help me at all. Next thing I'm going to do is I'm going to go to the next one, and I've got 8. There we go. I've got 8 here, a 0 here, and a 0 here. And since I am looking for, I'm in the negatives, so which one of these is going to be my smallest number? Do I have a tiebreaker yet for my smallest number? 8 is bigger than 0, but I'm in the negative side. So is 8 going to be less than or greater than? Less than. It's going to be opposite, right? So I know between these, my smallest number is going to be my -8 repeating. Okay, that's going to be my smallest number, which is this one right here. I'm just writing it shortcut there at the bottom. Now, between the other two, I don't have a tiebreaker yet, so I got to go out one more. So I'm going to go out here to the 0 and the 8. And between these two, which one is my least smallest number? Yeah, the 0.80 repeating, right? That was my repeating. That was this one right here. And then what that leaves is my negative. Whoops, I didn't put negative on all those. -0.8. And that was just an ending number, so I don't have to put all those zeros on there when I write my answer. And I did forget my negatives, so I'm going to add those real quick. And then that is ordering those 3 numbers. I converted them all to decimal. I took them all out to the same number, so I had a good comparison. And then I used my tiebreakers one at a time. And in the negative side, you just have to kind of flip your switch and remember that the greater one is actually the smaller one. So if I'm listing them from least to greatest, I've got my least number and then my middle number and then my greatest numbers there at the end. Okay? Any questions? All right. For those of you at home, click load and then show all your work in Kami, and make sure on your homework, number 1, 3, and 5 on your homework, you need to show all of your work for long division. And then 7 all the way down to the bottom of the paper, you can use your calculator, but you still need to show the work like I did here. If you're using your calculator, you need to actually write what the decimals are, and then you can decide which one is greater than or less than. When you're comparing them and writing them in order of greatest to least, I need to see the work like I did down here. This is where you convert them all to decimal and then order them. Let me know if you have any questions.